Chapter 25 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, a Geographical Reader, by Harold Wellman Fairbanks. Chapter 25. Gold and Gold Mining. Gold derives its value partly from its purchasing power, partly from those properties which make it serviceable in the arts, and partly from its beauty. The high esteem in which gold money is held is as much the result of its comparative rarity as of its physical properties. Among nearly all the nations of the world it has been agreed upon as a standard of exchange. Gold has one disadvantage as a medium of exchange. It is rather too soft to wear well. But this difficulty is overcome by alloying the gold with another mineral of nearly the same color, copper for instance. In order that we may understand better the position which gold occupies in the arts and trades of the world, let us compare it with other metals, and first with platinum. This mineral is far less abundant and has many properties which make it valuable in the arts. Like gold, platinum is malleable and ductile and does not tarnish in the air, but it differs from gold in not being easily fusible, so that it is used in the laboratory for crucibles. The steel gray color of platinum is, however, so much less attractive than the yellow of gold that it is not used for ornamental purposes. An effort was made at one time by Russia, where a comparatively large amount of platinum is found, to coin this metal into money, but its continued use was not found practicable because of its changing price in the markets of the world. If the leading nations would agree upon a fixed value for platinum, it might be used like gold as a medium of exchange. Silver is brighter and more attractive than platinum, but is of little use in the laboratory. It has been found in recent years to be so much more abundant than gold that its value has decreased greatly as a commercial article. In our country, when coined, it has, like paper money, been given a value equal to gold. The diamond has a value far exceeding that of gold, but this value is dependent almost wholly upon its ornamental properties, although the brilliant stone is also useful as an abrasive and cutting agent. From these facts it is evident that gold, because of its rarity, its physical properties, and its beauty, combines a larger number of desirable characteristics than any other mineral. Gold can be found in very small quantities nearly everywhere. It is present in all the rocks and also in sea water. The gold that is distributed in this manner is of no value to us, for it would cost many times as much to obtain it as it is worth. Nature has, however, concentrated it for us in some places. In portions of the world where the crust has been folded and broken, there are veins of quartz extending in long, narrow, and irregular sheets through the rocks. This quartz is the home of the gold, and it is usually found in hilly or mountainous regions. Do not mistake the yellow iron pyrites for gold. Pyrites is brittle, while gold is malleable. You can hammer a little grain of gold into a thin sheet. Do not make the mistake, either, of thinking that the shining yellow scales of mica which you can see in the sand in the bottom of a clear stream are gold. These yellow minerals that look like gold have been called fool's gold, because people have sometimes been utterly deceived by them. Upon the Pacific slope minerals are now being deposited in some of the openings of the rocks from which hot springs issue. A study of these springs has led to the opinion that the gold-bearing quartz veins were formed in a similar manner, but at a very remote time in the past. The milky or glassy quartz, which is so hard that you cannot scratch it with the point of your knife, the little grains of pale yellow iron pyrites, and the grains and threads of gold scattered through the quartz were at one time in solution in water. This water came from some region far down in the earth, farther than we can ever reach with the deepest shafts, and there, where it is very hot and the pressure is great, the water dissolved the little particles of gold and other minerals from the rocks, and then, gathering them up, bore them along toward the surface, depositing them as solid particles again in the form of veins in the fissures through which the stream was passing. As the rocks upon the surface decay and the crumbling material is carried away by running water, the gold, being very heavy, washes down the hillsides and is at last gathered in the gulches. This fact explains why we find gold both in veins and in the gravel of the streams. Getting gold from the veins is called quartz mining. Washing it from the gravel is called placer mining, and if the gravel is deep and a powerful stream of water is required, the work is called hydraulic mining. Everyone has heard of the Mother Lode of California. Every miner wishes that his mine were upon this famous lode, which is made up of a large number of quartz veins extending along the western slope of the Sierra Nevada mountains, and is marked by hundreds of important mines. A line of towns marks the course of the Mother Lode for over 100 miles. They are almost entirely supported by the gold which the lode supplies. The gold first discovered in California was placer gold. After the miners had worked over the stream gravels and had secured all that they could in that way, they began to search for the home of the gold. It could not always have been in the creek beds, and the miners were correct in thinking that it must have been washed from some other place. Gold was so frequently found in pieces of loose or float quartz that this fact finally turned their attention to the quartz veins, which were numerous upon the mountain slopes. Then came the discovery of the series of great quartz veins now known as the Mother Lode. When the miners first found the quartz flecked with gold, they used the simplest means for separating the two substances. If the quartz was very rich in gold, it was pounded and ground fine in a hand mortar. Then the lighter quartz was washed away and the gold left. The miners also made use of the Mexican arrastra. This is a very crude apparatus, and is employed even now by miners who cannot afford to procure a stamp mill. To build the arrastra, a circular depression 10 or 12 feet wide and a foot or more deep is made in the ground. This depression is lined with stone, which forms a hard bottom or floor. 4 bars extend outward from an upright post placed in the middle of the floor, and a large flat stone is fastened to the end of each bar by means of a rope. A horse is hitched to one of the bars, which is purposely left longer than the others. The ore is thrown into the arrastra, and water is admitted a little at a time. As the horse is driven around, the stones are dragged over the circular depression, crushing the ore and setting free the gold. This way of separating the gold was too slow, and in a short time the stamp mill was invented. It has grown from a very simple affair into the great mill which crushes hundreds of tons of ore in a day. The iron stamps each weigh nearly half a ton. They are raised by powerful machinery and allowed to drop into succession upon the ore, which is gradually fed under them. The stamps crush the ore to a fine sand more easily and rapidly than could be done by any other method. Water is kept running over the ore, and as fast as it is crushed, sufficiently fine for the particles to pass through a wire screen, the water with which they are mixed is allowed to flow over large plates of copper, which have been coated with quicksilver. The latter mineral has an attraction for gold, and so catches and holds most of the particles, no matter how small they are. The compound of gold and quicksilver is a soft white substance known as amalgam, utterly unlike either metal. When the amalgam is subjected to heat, the quicksilver is driven off in the form of a vapor, and the gold is left pure. The quicksilver vapor is condensed in a cool chamber and is used again. The iron pyrites in the ore contains gold which cannot be separated by the crushing process, and a machine called a concentrator has been invented to save this also. After passing over the copper plates, the crushed rock and pyrites are washed upon a broad flat surface, which is moving in such a way that the lighter rock waste is carried away by the water. The pyrites now appears as a dark, heavy sand. This sand is placed in a roasting furnace, where the sulfur is driven off and the gold and iron are left together. Now the gold is dissolved by means of chlorine gas, with which it unites in a compound called gold chloride. From this compound the metallic gold is easily separated. All this may seem a complicated process, but it is carried through so cheaply that the ore which contains only $2 or $3 to the ton can be profitably worked. Not all the quartz veins carry gold. There are many in which not a single speck of the precious metal can be found. Gold usually prefers the society of quartz to that of other substances, for minerals, like people, seem to have their likes and dislikes. Along the mother lode, however, gold is sometimes found in little bunches and stringers scattered through slate. In such cases the slate is mined and sent to the mill. Some miners devote themselves to pocket mining. They trace the little streams in the rock, and where two streams cross they sometimes find what they call a pocket. This is a mass of nearly pure gold of irregular shape, varying from a few dollars to thousands of dollars in value. This kind of mining is very uncertain in its results, for a man may make hundreds of dollars in one day and then not find anything more for months. The western slope of the Sierra Nevada mountains was once covered with the camps of thousands of placer miners. Piles of boulders and gravel are scattered along the creeks where the eager workers took out millions of dollars' worth of gold dust and nuggets. Now many of the streams and gulches are entirely deserted, but in other places where the quartz veins outcrop there are scores of stamp mills at work night and day, pounding out the gold. Some of the mines have been sunk more than a half-mile into the earth, and the gold is still as abundant as ever. In some portions of the mountains hydraulic mining is more common than quartz mining. Years ago many of the rivers occupied different channels from their present ones. The gravels of these old channels in the Sierra Nevada mountains and in other parts of the West where gold-bearing veins occur are rich in gold. In these channels the gold is so deeply buried that it cannot usually be obtained by means of pick and shovel. In order that the overlying gravel may be removed as cheaply as possible, water is supplied by means of ditches, often many miles long. From some nearby hill the stream is conducted down to the mine in strong iron pipes. It thus acquires a great force, and when directed against a gravel bank rapidly washes it away. Torrents of water-bearing boulders, gravel, and sand, together with the particles of gold, are turned into sluice boxes lined at the bottom with quicksilver. This metal catches the gold and forms an amalgam as it does in the quartz mills. End of chapter 25.